Hey, hey everybody, today I will be explaining about redox reaction. So, the first thing that I will be explaining is the definition of a redox reaction. The second, the types of half reactions. The third is to how to determine half reactions in a redox equation. And the fourth one is how to balance a redox reaction. So first, what is a redox reaction? Now, redox reaction is a reaction in which electrons of an atom in a substance are transferred to an atom of another substance or the same substance. The word redox comes from two terms, which is reduction and oxidation. The second one, types of half reactions. The first one is oxidation reaction. Now, oxidation reaction is a half reaction that involves the loss of electrons. The substance that carries atoms that has lost electrons is called a reducing agent. And for the second reduction half reaction, it is called the reduction reaction. This is the half reaction that involves gain of electrons. So compared to oxidation reaction, which has loss of electrons, the reduction reaction involves the gain of electrons. Now, the substance that carries atoms that has lost electrons is called an oxidizing agent. Now, there are three ways to determine half reactions. First is to see the gain or loss of hydrogen. The second one is to see the gain or loss of oxygen, and the third one is to see the gain or loss of electrons. For the first one, redox as gain or loss of hydrogen, there are two acronyms which could help you on remembering or memorizing the terms. So first, LoRa, which is the short version for loss of hydrogen, is oxidation, and its substance is reducing agent. So as you can see from the capital letters, this will form the acronym LoRa. And for the second one, GROA, this is the gain of hydrogen is reduction, and its substance is oxidizing agent. Now for this example right here, as you can see, ammonia with added with bromine will yield nitrogen gas and hydrogen bromide. So how do we tell which one is the oxidation reaction and which one is the reduction reaction? So follow the acronyms above. So the loss of hydrogen is oxidation. Now, as you can see here, ammonia will lose its hydrogen, forming nitrogen gas. So we can say that this is oxidation. And for bromine, it will form hydrogen bromide, which is the gain of hydrogen. So we can call that as reduction. Right, moving on. Okay. The second one is the redox as gain or loss of oxygen. Now, there are also two acronyms to help. So first one is LoRa, which is simply loss of oxygen is reduction, and its substance is oxidizing agent. And for the second one, gain of oxygen is oxidation, and its substance is called reducing agent. So for the example here, as you can see, copper oxide with carbon will yield copper and carbon monoxide. So how do we tell which one is the oxidation and which one is the reduction? Well, we follow the acronyms above. So first, loss of oxygen is reduction. So you can see copper oxide will lose its oxygen forming copper. So we can say that this is called reduction. And for carbon, here, following the GORA acronym, gain of oxygen, so carbon will form carbon monoxide. So it will gain oxygen, and we can call that as oxidation. For the third one, redox as gain or loss of electrons. So here we also have two acronyms. The first one is GORA, which is the loss of electrons. It's called oxidation, and its substance is reducing agent. The second one, we have GEROA, which is the opposite. So gain of electrons is reduction, and its substance is called oxidizing agent. So for the example here, we have iron trioxide and carbon monoxide will yield iron and carbon dioxide. So first, to implement these acronyms, we have to assign oxidation numbers to each substances. So for example here, oxygen, it has -2 and -2. So this will be -6 to make it balance. This will be 2 iron will be +6 charge. So 1 iron atom will be +3. Next, for carbon monoxide, oxygen has -2 charge, and carbon will have +2 charge. Right, so let me erase this one. Okay, so so for iron, as it is the only atom or free element, this will have 0 charge, and here oxygen has -2. -2 will be multiplied with 2, and carbon will have +4 charge. So now we can implement the acronyms. So loss of electrons is oxidation. So which substance has loss of electrons? Here, as you can see, carbon went from a +2 charge to a +4 charge. So that means it has lost electrons. So this is called oxidation. And for the reduction, as we can see here, iron trioxide has gained electrons from +3 charge to 0 charge. So this will be called a reduction. So now we are going to learn how to balance a redox reaction in acidic reaction. Acidic solution. There's a type I mistyped here. So the steps to balance a redox reaction in an acidic solution is first we add H2O or water to balance oxygen, while we add H plus to balance hydrogen. Next, we also can add electrons to balance the charges on both sides. And next, the last step is to equalize the numbers of electrons on both half reactions, so on reduction and oxidation reactions. And then we combine both of the half reactions. So, for example, here, balance the redox reaction, manganese oxide and chromium oxide or chromite, if I remember wrong. I'm sorry. and it will yield manganese and chromate. Okay. This is hard to remember. Okay, so I'll write here the reaction. Okay, so we assign oxidation numbers. So here oxygen has -2, so manganese has +4 charge, and here oxygen has -2, and -2 times 3 will be -6, and chromium, since this has a negative charge, this will be a +5. So +5 plus -6 will be -1. And here manganese will have a 0 charge since it is a free element. And here oxygen has -2. Chromium will have +7 because this is a negative charge here. So let's determine the redox reaction. So here, which has the loss of electrons. So following the acronym from before, LEORA, loss of electrons means oxidation. So here we can see that chromium has gone from +5 charge to a +7. So this will be oxidation, while manganese oxide here will undergo a reduction reaction since it went from +4 charge to a 0. Now we separate the reactions for oxidizing reaction. So CrO3 will form CrO4. So first, to balance the oxygen in both sides, we can hold on. Okay. So here we have equal 1 to 1 on both sides, and for the oxygen, this one has 3 and this one has 4. So we need to add one more oxygen on the left side. So we add 1 H2O. So this will make it into 4. And since it has added 2 hydrogen, we need to add 2 H plus to balance it. Okay, so now what we need to balance is the electron count. So here we have negative, so -1 here, and here will be 2 times 1, and then -1. So this will be +1, but we want to balance both both sides. So here we add electrons, and since we want to make both sides -1, we add 2 electrons. So -2 result to -1. So this will be the oxidation equation. Now let's move to the reduction reaction. So for the reduction reaction, here manganese oxide will form and will yield manganese. So as we can see here, we have equal manganese on both sides, and for oxygen on the left side we have 2, so we have to add 2 more oxygen on the right side. So we add 2 H2O. So this will be 2, and since we added hydrogen on this side, we will add 4 H plus, since 2 times 2 is 4. So 4 and 4. And now we need to balance the electron charge. So on the right side we have 0, and here since we added H plus, this will be +4. So we need to add 4 electrons. -4, sorry. So this will be the reduction reaction. And now for the next step, we have to remove the electrons from both sides. So on the oxidation reaction, we will multiply this by 2. Next, since we multiplied it by 2, the electron charge on the oxidation reaction will be 4, and it is the same as reduction reaction, so we can cancel. And then can cancel H2O since it has 2, and we can remove 2 H plus on the left side. So now we just add all of these together. Oh, I'm sorry, this should be where is it? This should be gone because this was 4. Okay, so what's left is so this will be the final balance equation. So now moving on, balancing a redox reaction in basic solution. So in basic solution, first we add H2O to balance oxygen while we add H plus to balance hydrogen. We can also add electrons to balance the charges. Next, equalize the number of electrons on both half fractions and then combine. Now, so as you can see here, from step 1 to 3, it is similar to the balancing redox reaction in acidic reaction, but for the basic one, there are two extra steps. So step number 4, for each H plus, we add OH or hydroxide to both sides, and we combine hydrogen with hydroxide to form H2O. And then we simplify the equation by cancelling as much H2O from both sides as possible. So let's get to the example. So here, balance the equation redox reaction. Bromate or bromide, I forgot. I need to review this more. Plus Ag or gold will yield G positive charge, and BrO2, I forgot the name. So first, let's assign oxidation numbers. So here, oxygen has -2 charge, while bromine has -2 times 3, and then it will be -6. So bromine has +5. Ag here is a free element, so it will have 0 charge. Here you have 1 because it is +1, and here -2 for oxygen, and -2 times 2. This will be +4. So let's assign. Let's use the acronyms from before. Vayora, loss of electrons, is oxidation. So which one it has the loss of electrons? So here, went from 0 charge to +1 charge. So this is loss of electrons. Oxidation. Wait, yes, oxidations. And for reduction, here BrO3, bromine went from a +5 to a +4. So this has loss of electron, a gain of electron, sorry. So this will be a reduction. Now, let's separate the half fractions. So for oxidation reaction, Ag one Hg plus. Let me remove this. Okay. So here, since there are no need to add H2O or H plus, we just need to balance the electrons. This has 0, this has positive 1, so we add an electron to make it 0. So this is the oxidation reaction. Now moving on to the reduction reaction. Okay, so BrO3 will yield BrO2. So here, let's balance. So here, Br, bromine, there are 1 bromine on each side, so that's balanced. And for oxygen, this side has 3, and the right side has 2, so we need to add H2O. And since we added H2O, we need to add H plus on this side, the left side. So there will be 2 H hydrogen on the left side and 2 hydrogen on the right side. Now balance the electrons. So on the right side there will be 0 charge, and on the right side 2 times 1, 2 minus 1, so we need to add an electron. So now let's balance, let's simplify the electrons on the both half fractions. So here there's 1 electron and here there's also 1 electron, so we just simply cancel both electrons, and now we combine both reactions. Okay, so this is the equation, redox equation. If this was an acidic, in acidic solution, this would be the final result. But since we're trying to find the redox reaction in a basic solution, we have 2 more extra steps. So let me erase this part. Okay, so step number 4, for each hydrogen, we add a hydroxide on both sides. So here, there are 2 hydrogen, so we add 2 OH or 2 hydroxides on both sides. And then we combine the hydroxide with hydrogen to form H2O. So I'll write it up here. So since there are 2 hydrogen and 2 hydroxide, this will form 2 H2O. Now the last step is to remove as much H2O as possible from both sides. So here there's 1 and here there's 2, so we can cancel here. This will leave 1 H2O. So the final result will be here will be the final result. So that's it for the video. I hope this explains the redox reaction quite well. Yeah, and that's it. Thanks for watching.